Alright guys, welcome to our channel Code with Sunny, and today we'll be discussing the hard problem merge k sorted lists. Like we have to merge k list that will be given to us, and there will be some criteria also. We will discuss that. Okay, and it is the hard problem of the lead code. So we will be given an array of k linked lists where each linked list is sorted in ascending order. Like there will be k list, and each list will have the nodes sorted in ascending order of their nodes values, and we have to merge all the linked list into one sorted linked list, and we have to return that. Okay, so we are going to discuss the examples also. So first let's look over the constraints. So k will be the list length, and k will be at most 10 raised to the power 4, and every list will contain at most 500 nodes, and list are sorted in ascending order, like every list ascending order of their nodes values, and the total number of nodes will not exceed 10 raised to the power 4. Okay, so this is quite important because this will help you to understand how the complexity will work. Like you can see, if total number of nodes is 10 raised to the power 4, so you would be thinking of O of n or O of n log n type solution, like because 10 raised to the power 4 log 10 raised to the power 4 will fit in the time constraints. Okay, so first let's understand how we are going to do this with the help of this example. Let me pick up this and explain. So we would be having a list like 1 4 5, and this was the first list, and would be having another list 1 3 4, followed by the last one. You can see 2 and 6. Now you can see every list is sorted in ascending order. Okay, so we have to find out we have to find out a new list. Let's say a new list containing nodes. Like these nodes will contain the values of all these nodes, like 1 4 and 5, 1 3 4 and 2 6. Okay, so we have to find out a list containing k into n nodes, like the total nodes present in this k list, and that list should be sorted in ascending order. Okay, so you can see, if we put all these nodes into one list, and we are going to return the head of the list, it should be like 1 followed by 1. You can see this one, this one. Now the next minimum node value is 2. You can see this one, then followed by 3, this one, then followed by 4 and 4. You can see 4 4, then 5 and then 6, then 5 and then 6. So we need to return the head of this linked list. This is our new linked list, which will contain all the k into n nodes. There are total number of k into n nodes. K is the total number of list, and n is the number of nodes present in that particular list. Okay, so yeah, you can see like all the list, there is not guaranteed that all the list will have same size. Suppose this is of n1 size, this is of n2 size, and this is of n3 size. You can see n1 is exactly equal to n2, but n2 is not equal to n3, and n1 is not equal to n3. Okay, but for general case I am writing this one. Okay, so it should be like summation, let me denote it as capital N, total number of nodes present in all those lists. Okay, so k into n in general I am talking about. We need to return this head of this new linked list. So you can see it is actually matching with this one. So 1 1 2 3 4 4 5 6. We need to return the pointer. So the very first way, which is actually the brute force, is the way is like you are going to store all the node pairs. Let me write down node pairs into into a vector. Okay, so you would be you would be denoting a nodes value and node address. Okay, so stored, let me write down, stored all the nodes, stored all node pairs, and the pair is of type this one, into a vector, and we are going to sort the vector in ascending order. If you are going to sort the vector in ascending order, you can easily observe that all the node pairs will be sorted on the basis of nodes value. So if the nodes value, like the nodes are sorted in, with respect to nodes value, we would be having 1 1 2 3 4 4 5 and 6. Okay, now also every element will contain the two datas, like this is the value, right, and it will contain the nodes address also, nodes address. and here also it would contain node's address. Okay, and like every element will contain node's value and node's address. Now we can easily link the next pointer of this node address to this one, and similarly this node's address to of this one, because we have the data of node's address, so we can easily link their next pointer, and the last one would point to a null pointer. Okay, and we can easily return the node's address of this node because this is the minimum node and we need to return that. So but this is the like entire like brute force approach, and the time complexity of this approach is not good, because we need to have the best approach to solve this problem. So let me first show out the code how this is going to work, then we will move on to the optimized approach. Like time complexity of this one would be n log of n, where capital N is going to denote the total number of nodes present in this entire list. Like there are k list, so we would be having the sum of all the nodes, and it can go at max 10 raised to the power 4 as denoted in this problem. You can see sum of all the nodes won't exceed this one. Okay, so what I've done is like I have made a pair of sorted lists, and I've iterated in our actual all the head pointers of k list. You can see if the head pointer is not null, we are going to store it in the form of a pair heads val and head, like the nodes value and head and their address, and we are going to move on to the next pointers. Okay, like we are storing all the nodes with respect to nodes val and their address, and if the sorted list, which is actually the vector, is empty, our head node will be a null pointer, so we'll be returning that. Otherwise we are going to sort all the nodes value in non-decreasing order. You can see I have used a sort function. It will sort the vector on the basis of their nodes value. Okay, and now we have to link their next pointers. You can see I have linked the next pointer of I minus 1th node with this ith node, okay, in the sorted list. Also you need to take care that the last one should be pointing to a null pointer, and we have to return the head pointer, right? So we'd be returning the address of the node of the very first element present in our sorted list. So this will give you all test cases passed, but the intended solution is not this one. We need to have some more optimized solution, like in terms of time and space. Okay, so let me write down there are many ways to do that. Like there are popularly two ways. So the very first way would be using a min heap, or in more general terms you can say that I'm going to use a priority queue. Okay, and there is another method also, divide and conquer. Divide and conquer. Okay, so I will give out a brief idea for this approach, and for this approach I am going to discuss in detail. So divide and conquer approach, let me talk about this one. First would be like, suppose you have two sorted array, like here we have k sorted list, right? K sorted list. Okay, consider k as 2 right over here. Okay, so if k as 2, we need to merge two list, right? We need to merge two list, and this can be easily done in O of n plus m time, that is the linear time. Okay, and what about if we have k sorted list? In that case you need to divide, suppose it is from 1 to k, you need to divide this entire k list into two ranges, this one and this one, and you need to perform a merge sort type, like dividing the entire length k into two parts, then again two parts, then again two parts for every part, and we need to sort them, like we need to sort this entire k by 2 list and this entire k by 2 list. And if k by 2 is like again, yeah, so we need to again divide it into two parts and divide into two parts and divide into two parts and divide into two parts. And suppose we have merged already these two, one, like these two are already a sorted list, then we need to perform a merge operation similar to the case of merge operation. So this is actually a divide and conquer algorithm which you can use to solve this problem. Okay, so but yeah, you can implement that, and if in case if you are getting some doubts, you can approach us towards through the comment section of the video. For now, let's discuss how we are going to use the min heap to solve this problem. That is, we are going to use a priority queue, obviously. Yeah, so Okay, so let me write down first. Idea is priority queue. Okay, so now you can easily observe that since all the lists are sorted in ascending order, so what would be the very first node that would be in our that would be present in the sorted manner, like if you consider all the nodes. So the very first node would be among any of the nodes among these three nodes, right? Like any of the node among these three nodes. So what I'm going to do is, like, I'm going to push all the head pointers first in a priority queue. So head pointer, like priority queue, will store again the pair containing nodes val and the node address. Okay, so you can see, since priority queue it is a min heap now, which I am using, it will sort all the nodes on the basis of nodes val, like picking up the minimum one. So you can see initially the priority queue will contain, let's say, it is of head 1, head 2 and head 3. Okay, so the priority queue will contain 1 comma head 1, and again it would contain 1 comma head 2, and it would contain 1 comma head 3. So each time I will push, like, for the very first time I will push out all the head pointers of the k list into the priority queue, and it will extract out the that node which has the minimum value. Okay, and that will be the, like, first volunteer for our the sorted list. Okay, so it will extract out the any like the very first smallest node with the smallest value. You can see this one. Okay, so this will be our head node, so I am picking out this one, and this will point to some node which I am not aware about that. Okay, now this node is being used, right? So we need to cancel this node, but when this node is being used, we will we will push out the next element if present in this list into the priority queue. Like this element is used right now. Okay, so we will cut it out, and what is the next node of this h1? So next node of this h1 is node with value 4. So we will insert the pair 4 comma head 1. So my head 1, which is new head, is pointing at this node, and it is containing the value 4. Okay, now again we need to extract the minimum one. Okay, so this one is actually 2, sorry, this one is actually 2. Okay, so don't get confused. Okay, so we need to extract the next minimum one among these 4, 1 and 2. You can see this is the our volunteer node. So priority queue will automatically sort all the nodes with respect to their nodes values. So the next node would be 1, and this h2 is utilized over here, so h2 will move out to the next position. Okay, so this one, so I will insert this again, 3 and h2. Okay, so doing that in the similar way, you are going to say, yeah, h3 is also used, so we will cut it out, and we will move out h3 to this position. So we will have 6 comma h3. Now again picking up the minimum, so this one is taken, so this will be cut out, and h2 will go over here. So we would be having, so 1 2 followed by this 3. Okay, and yeah, now again we need to extract this, so this will be cutted, and like we have 4 comma h2. Now again we need to extract the minimum, so you can either put out this one, extract this one, or extract this one. Let's say I am going to extract this one, so 3 would point to 4. Now you can see h2 has no next pointer. Okay, so this will be, like, we are done with this list, so we are not going to push any node from this list. Okay, so from 4 again we have 4 which would come from this one, so h1 would point to this one, 4 then would come from to 5, and then come from to 6. Like this is the entire process. Okay, so let's talk about how we are going to like what is the time complexity and space complexity for this approach. Then we'll move out to the coding part. You can see that pushing a node into a priority queue takes a logarithmic time. So the complexity, the one factor will be log of k, and also anytime we have only k nodes present in the priority queue, and the size of the priority queue will be exactly k, because there are k lists and we are always pushing exactly k nodes. Like every time we will be having k nodes at max. Okay, note that I am talking about the maximum nodes. Okay, so log k. And what is the total number of nodes that we are going to push it into the priority queue would be k into the n, where n is the general case. Okay, where like it should be like n1, for like n1 is the length of the first list, and n2 would be like the length of the second list, and so on. So the time complexity would be k of n, k into n log k. So this would be tc. In more general terms, you can write this as capital N log k, where capital N is going to denote the total number of nodes. Okay, and space complexity would be like log k, the size of the priority queue. Okay, so this is the method of priority queue, which is the simplest one. You are going to use this one to solve this problem efficiently. So let's look over the code, how this is going to be implemented efficiently. Okay, so I'm going to use a priority queue which will store the current pointer of all k list. Note that I've used a max heap. It doesn't matter because I'm going to push out the negative value of this like negative of nodes value. Okay, so it will automatically sort the nodes in ascending order, like because we are pushing out the negative value. Okay, so if head is not a null pointer, we will push out all the head pointers of this k lists. Okay, so my new head would be pointing initially to null pointer, and we need a previous node to link all those nodes. Okay, so extract the node with minimum value from the priority queue, and if my new head is still not assigned, assign it with this current node, and this will be the like very first node. Okay, and if we have already found the new node, we are going to link the previous node with this current node. Okay, and note that we need to update each time the previous node. Okay, and just to check it out, like move out to the like we have the current node, right, and move out to the next node. Like if there exists a next node, we need to push out that next node of the current list. Okay, note that I'm pushing the negative value of the current nodes. Okay, and yes, if this all goes well, we need to return the new head, which would be the head pointer of this list, which would contain all the nodes from this k list, and this list is going to be sorted in ascending order, because each time we are going to extract the minimum element from the priority queue and linking the nodes. Okay, so if you guys have still any doubts, do not if you guys have still any doubts, do let me know in the comment section of the video, and thank you for watching this video.